We are now going to work some problems using some more formulas. Two different formulas, double angle and half angle. Double angle, if you double something, you multiply by 2, correct? So double angle is dealing with 2 theta, if my angle is theta. Half angle would be theta divided by 2. Now if we go back to the formula sheet, the same one where we use sum of difference of 2 angles, further down we have a section labeled double angles. Once again, for this little formula sheet, they call the angles U. So you notice here's a formula, the sine of 2u equals 2 sine u cosine u. So the key thing is you're trying to find the trig function of a double angle. You can rewrite that double angle trig function as just the sine and cosine of the angle. And we'll do a couple problems later on. Now what's interesting is here in the middle for the cosine of 2u, or the cosine of the double angle, there's actually 3 different formulas. So you can, as you're working a problem, you can choose whichever one you like. Usually I try and choose the one that I think might be easiest to work out the math. And then finally the tangent of 2u. But then also, later on we have formulas for the half angles. It's interesting for half angle formulas. First of all, these are going to, I'm warning you, these are going to be very messy problems. Because look at here, all of these have a square root. Inside the square root are fractions. So it's just the math is going to be messy. But one extra level of complexity is that for these formulas, you see in front of the square root is plus and minus. Now that does not mean that you're going to have 2 answers, a plus or minus. That simply means the formula that you're going to need to use on some problems, it'll need to be a positive answer, and on other problems it's a negative. So it's not going to be both. Let me take a minute to explain that before we start. So in algebra, if you were solving this simple equation, take the square root of both sides. Square root of x squared is x. Square root of 9 is 3. But you were taught in algebra, actually, it's not just 3. It's plus or minus 3. Which means, actually, you have 2 solutions. Sometimes you write it like that. When I write these formulas, instead of u or v, I'm going to use theta because I just like to use theta from angles. So here's the half angle formula for the sine. And once again, the key to these formulas are, even though I'm trying to find the half angle, in the formula itself, I just have the cosine of theta. So that's why we can work these out. But the point I'm making now is, you see this plus or minus? That does not mean there's going to be 2 answers, a positive answer and a negative answer. Instead, it means before you even do this calculation, you have to go back and determine, should my answer be a positive or a negative result? And it goes back to, you go see what quadrant which quadrant the angle theta over 2 is going to be in. So if you do a problem where it turns out you figured out that this pi over 2 angle is in quadrant 3, then your formula, you put the minus in front, because you know in quadrant 3 the sign has to be a negative number. If you decide the answer, or the half angle, theta over 2 is in quadrant 2, then your answer is going to be the positive version. So we will do these problems later on and you'll see that, but that's a heads up. So just taking one more quick look, the other thing I wanted to mention before we start working some problems are, look at these half angle formulas. All of them, all you need to know is the cosine. If you know the cosine of your angle, then you can do all these. All right, so there's really two kinds of problems you're going to have to work. Now, the first kind of problem is very similar to what we did with sum and difference formulas. And by that I mean, sometimes you may be given a problem and you're asked to find, let me find my, so for instance, let's do this problem. They want to know the cosine of 105 degrees, and they want to know the exact value. Now, in the instructions for this problem, they actually will tell you, use the half angle formula and determine this. I guess I can, so you're not left to guess what they're looking for. Use the half angle formula to solve this. Since we're looking for an exact value, we can only give exact value answers for special angles. Well, 105 degrees is not a special angle. If you look on your unit circle, you go from 90 to 120. 105 is not in there. However, what you realize is, so this is where I said it's sort of like the sum and difference formulas, where in this case, 105 degrees would be the same thing as 210 degrees divided by 2. I do that because, lo and behold, 210 degrees is a special angle. So what I'm really doing is saying the cosine of 105 degrees, I'm going to call the cosine of 210 degrees over 2. So now if I think of my half angle formula, you can see that the 210 degrees is like theta. And now I can use the double angle formula. So I get my formula sheet and I say the the half angle for cosine is this. I'll just write it down. Plus or minus 1 plus cosine of theta over 2. Where theta now is 210. So in a minute, I'm going to plug in 210 here for theta, and then I can do this calculation. But before I do the calculation, I have to decide, should the answer to this problem be a positive or negative number? So this is my angle. This is the angle I'm looking for, my half angle. The cosine of 105, what quadrant is 105 degrees in? Well, we just looked. 105 degrees has to be in quadrant 2. So this is a quadrant 2 angle. What do I know about the cosine in quadrant 2? The cosine's like x, and that has to be a negative number. So what I typically will do in my formula, I just sort of mark out whichever one doesn't apply. So now this is the formula I'm going to use. So the cosine of 105 degrees which is, just to make it very clear, I'll write it out again, which is the cosine of 210 degrees over 2. Since this is my theta, 1 plus the cosine of 210 degrees over 2. And because this is a special angle, I know the exact value of cosine of 210. So here's where it gets messy now. Once you actually start to do the math, you have fractions under square roots, and it can be sort of messy algebra. So the cosine of 210, 210 is down here, cosine is negative square root of 3 over 2. All that over 2, which is all inside the square root. So now I need to do simplifying, because they're not going to want an answer like this. So now it's like algebra. So let's do this. I will try not to skip any steps. So 1 plus a negative square root of 3 over 2, let's just rewrite that as 1 minus square root of 3 over 2, all over 2. I'm going to now combine these into one fraction. So to do that, I'm subtracting here. I have to have a common denominator. I can convert 1 to be 2 over 2. So therefore, I can make this one fraction. 1 minus square root of 3 over 2 is the same thing as 2 minus square root of 3 over 2. So I replace that. So I have 2 minus square root of 3 over 2, all over 2. Now I have a complex fraction. I'm not going to take the time now. Hopefully you all remember and know how to simplify a complex fraction. In this case, this 2 moves up to the bottom of this fraction. So like a shortcut. So it's 2 times 2, which is going to be 4. Now, once again, just not skipping steps in case some of you haven't done this for a while. When you have a fraction under a square root, you can break it up into separate square roots. Now, we know the square root of 4 is 2. So this actually would be the final answer. It's a little messy, but turns out that is the correct answer. Let me do one more where we're asked to find a trig function of an angle, which is not a special angle, but by using the half angle formula, we can go ahead and figure out the exact value. So for this one, it's a little trickier. That's why I want to do it. You see one like this in the homework. They say use the half angle formula and determine the exact value of the sine of negative 7 pi over 8. So the negative angle makes it maybe a little different. The key here is 7 pi over 8 is not a special angle. It's not on the unit circle. However, especially since they told me to use the half angle formula, I realize that 7 pi over 8 sort of like a complex fraction. 7 pi over 4 divided by 2 is the same thing as 7 pi over 8. And this is a special angle. So we can think of this, when we go use our formula, 7 pi over 4 is going to be our theta. I should probably put the minus in here. So theta is really going to be minus 7 pi over 4. So just to be clear, once again, here's what we're doing. We're asked to find the exact value of the sine of negative 7 pi over 8. This is not a special angle. I don't know how to get the exact value. However, I can rewrite this as negative 7 pi over 4 divided by 2. And because this negative 7 pi over 4 is a special angle, then I can go and use the half angle formula for the sine. So for the sine of the half angle, once again, go to my formula sheet, plus or minus square root of 1 minus, write it down, so it's plus or minus 1 minus cosine of theta divided by 2. And once again, before we start doing the calculation, I need to decide whether my answer should be a positive or negative number. So we're talking about the sine function. Here is the angle we're talking about. So let's go figure out where that angle is. If you think about our unit circle, so since we're doing negative angles, zeros here, over here would be minus pi, so we're going in a clockwise direction. If you want to, you can think of minus pi as minus 8 pi over 8, right? So where would negative 7 pi over 8 be? Maybe right in here. So we've just determined this angle's in quadrant 3. What is the sine? Always have to be in quadrant 3. It has to be negative. So before I start doing any calculations, I know this is going to be a negative answer. So let's go ahead and plug in. So it's negative 1 minus the cosine. My theta is like negative 7 pi over 4. So let's go back here. We have to figure out what's the cosine of negative 7 pi over 4. Here's what I do sometimes. I think of, especially for negative angles, I think of what's the distance for the positive angle. In other words, where is 7 pi over 4? If you look at your unit circle, 7 pi over 4 is down here. So here's 7 pi over 4. So I had to go 3/4 of the way and then another half, almost all the way around the unit circle to get 7 pi over 4. So if I want to go to negative 7 pi over 4, I have to go the same distance except in the opposite direction. So I would go like this and end up here. So negative 7 pi over 4 is up here. That becomes important because now I need to plug in what is the cosine of this angle. And I know it's going to be square root of 2 over 2. So 1 minus square root of 2 over 2 all over 2. So now the rest of the problem becomes just trying to simplify this with radicals and fractions and all kinds of messy stuff. So let's do what I did the last time. I'm going to go ahead and take 1 minus square root of 2 over 2 and make it into one fraction. So I'm not going to show it again because I did it last time, but when you do that, you'll end up with 2 minus square root of 2 over 2. And all that is over 2, and all that stuff is actually under the square root. So now once again, complex fraction. This 2 goes up here, so I already have now 4 in my denominator. So I have 2 minus square root of 2 all over 4. And just like the last problem, I can break this up, and when I do, end up with 2 minus square root of 2 over 2. Once again, it looks pretty messy, but that's actually the exact value of the sine of negative 7 pi over 8. All right, so that's one of the things we use half-angle formulas for to solve problems like this.